Hi, my name is Brianne Law, and I'm going to be taking you through an article posted by Physics World, where they discuss the Eggbeater biomechanics that are performed in water polo and how they defy biomechanics and physics. Physics World is a news publishing site where they discuss new and exciting things that happen in the physics world. A study done by a university in Japan early this year used 6 male water polo players from first division and national level teams. They studied their Eggbeater kick to better understand the propulsive forces on water polo players' feet while performing Eggbeater. Eggbeater is the water sports version of running. Both have two main phases, and each phase leads to the next. Different pressures are applied to the ground when running in each phase, and just like Eggbeater, applies different forces to the water below the athlete to propel them forward or up. So comparing the running phases to the Eggbeater phases, phase 1, 2, and 3 in Eggbeater is the out kick, and that's very similar to the stance phase. In running, this is where the Eggbeater athlete is going to generate most of their force. And then phases 4, 5, and 6, which is the in kick, this is bringing the leg back around to then prep to do another out kick and produce more force. Very similar to running, where the swing phase is leaning back up to plant the foot and then produce force again. So relating the stick figure here to a real life body, the athlete in the picture shown above is just finishing up the in kick, so transferring from step 5 to phase 6, and then we'll come back to 1, rotating that circle around again. So now you can see in the video here, if you follow the right foot, how it is drawing a circle. Will the knees stay up, staying as close as they can to a 90-degree seated position. The foot is slightly everting and inverting and pointing and flexing as the athlete is drawing these circles with their foot. This is creating propulsion that keeps the athlete head above the surface. Hydrodynamic lift force is the main force that keeps the athlete suspended in the water while performing Eggbeater. This is caused by the flow of water over the foot and the leg of the athlete. So it is very similar to a plane wing. If the flow is faster over top of the foot due to the shape of it and the way that it is moving in the Eggbeater, then a low pressure area is created. If a low pressure system exists above the foot and a higher pressure system is located below the foot and the whole body will be pulled upwards into an area of decreased pressure, and this is referred to as lift force. So as you can see, higher velocity flow is above the foot, which creates less pressure, and low velocity flow creates more pressure, again attributing it to that lift, very similar to the way an airplane is able to take flight. Fast air moving over top, which is a lower force, slower air moving underneath the wing, which creates higher pressure and therefore more lift up, allowing the plane to fly or allowing our athlete to keep their head above the water. So the findings of the research were that the propulsive force exerted by water polo players during Eggbeater kick was characterized by a decrease in pressure on the dorsal side of the foot and acceleration of the foot. Specifically, the propulsive force increased with the pressure difference between the plantar side and the dorsal side of the foot. The propulsive force peaked when the foot had passed its maximum velocity and began to decelerate. This is the first time this characteristic was shown, and it indicates the significant role of water unsteadiness in estimating the propulsive force of Eggbeater kicking. So technically, when an athlete is performing Eggbeater, they apply forces and push the water down using the bottom of their foot, and the water has a reaction and pushes back up on the foot, resulting in more pressure on the bottom of the foot and inversely less pressure on the top of the foot. However, during the study, it was confirmed that significant pressures decreased on the top of the foot during the Eggbeater kick, and Newton's third law cannot be explained with the results because the pressure isn't increasing on the plantar side of the foot. This suggests that the pressure decreases on the top side of the foot also generates unsteady flow and related effects. So the pressure on the top of the foot are not relating to the pressures seen on the bottom of the foot, and these pressures may have attributed to leading edge vortexes. Leading edge vortexes form due to flow separation from the leading edges of the foot, like when these swans are landing in the water, and create these max crazy disruptions in the water like you are seeing now. So in Eggbeater, these decreased pressures above the foot increases the pressure difference between the plantar and dorsal sides, thereby inducing effects related to unsteady flow and to the propulsive or other fluid forces. So Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object. However, in the study, kick velocity peaks before propulsive force, and this should happen at the same time. So there was some water unsteadiness affecting the forces acting on the foot. The timing of the two peaks of propulsive force and kick acceleration are very off, and this is inconsistent with the Newton's second law of motion of acceleration. Since the acceleration of the foot produced by a net force was not directly proportional to the magnitude of the propulsive force up. So, propulsive force went up as the pressure difference between the top and the bottom foot got bigger. And the timing difference between these two peaks was about 4% of the cycle time, which is quite significant considering how fast an Eggbeater kick is. So from this study, we better understand how the propulsive force exerted by athletes doing Eggbeater kick has been characterized by a decrease in pressure on the dorsal side of the foot and acceleration of the foot at the same time. Specifically, the propulsive force increased with the pressure difference between the plantar and the dorsal side of the foot and peaked when the foot had passed its maximum velocity and began to decelerate. So for now, with the technology we have, Eggbeater is defying physics by not complying with Newton's second and third law, and we now better understand how the water unsteadiness or turbulent flow created by the kick of Eggbeater, specifically by the foot, help propel the athlete up just a little bit more.